Hello, how's it going? It's time for some more chemistry with Mr. Zed and the Zdog. How's it going today, Zdog?
Woohoo! Got the chemojo flowing, man.
Okay, so we have all of the glassware in the world. If I was to break this right now, I would be, out many dollars. I'd have to sell a few more buns and stuffies. We're going to be showing you guys how to do a titration, but more importantly, it's a two-step titration with a lot of really good lab skills involved. We are going to be first standardizing sodium hydroxide and then using that to titrate vinegar. Now, Zdog made a good point to talk about why we can't use sodium hydroxide as a primary standard. And the main reason is sodium hydroxide is this very powerful base. It comes in pellet form, usually, and it absorbs water like crazy. When did you put these on the dish, Zdog?
Just a few hours ago?
Yeah.
What are they looking like now?
Whoa, just about slipped onto my finger. That would have been very bad.
Corrosive.
It's very caustically corrosive. So they're all slimy, like it's absorbing water from the atmosphere, right? So that means if we're mixing it, we can't be 100% sure what the concentration is. So we have to double check it with a known concentration of something else called KHP. And KHP, we can measure out and make a very accurate concentration. And Zdog's going to be up here right away to talk about the first technique to get this going with our burette system. Okay, Zdog is setting up and getting himself safe. You will have this exact same graph and chart, and you are going to be following along with us today, filling in the titration table and then doing the math. So we're not putting numbers up there. Well, we might put some up there, but you're going to be doing most of the work. Okay.
Hey, we're back. Titration, analytical chemistry. Love it. My favorite part of Chemistry 20. Titrations are really important analytical chemistry skill. Can be used from anything from environmental testing, water samples, forensic samples. Our goal today is eventually to determine the amount concentration of some white vinegar to test the manufacturer's claim. In order to do that, the first part of the two-step process is to determine the amount concentration of our sodium hydroxide when reacted with our primary standard, which is KHP. You can see they're in a 1-to-1 mole ratio. In the burette will be our sodium hydroxide, that's called our titrant. In the flask, our sample or analyte, that's called KHP, which is potassium hydrogen phthalate, the abbreviation for that. We're going to be using the phenolphthalein acid-base indicator to determine the endpoint, the end of the reaction between these two reactants. I have prepared standard solution of KHP, and we'll be titrating 10 milliliter aliquots of this. The amount concentration is 0.15 moles per liter. To get started, we would take the burette and use this long-handled cleaning brush at a tall sink to thoroughly clean the burette.
Why would we do that, Zdog?
We want to clean out the burette to remove any contaminants. We only want our burette to contain our titrant.
Have you had kids that forget that step and get crazy data?
That's right. It's not working, Mr. Z. Oh, look at this weird color I'm getting. How could that be?
It's not pink. Mine turned blue. Well,
Yeah.
you done screwed up, child.
Yeah. Then what we want to do is rinse the burette with the titrant, and this should actually be done 3 times. Off camera, I have done this twice already. So just rinsing this into the sink a little bit, rinsing the stopcock into a waste beaker. Make sure that all of your containers are properly labeled so there's no confusion and no errors that way.
Why wouldn't we just rinse with distilled water?
Again, we want to coat all the surfaces of our glassware with our titrant or sodium hydroxide. We don't want any dilution or any chance of contamination.
You also want to make sure the valve at the bottom works, because some of them don't.
That's right. Make sure your stopcock's not clogged. Make sure that there
That's
are
the
no
worst.
air bubbles in the bottom of the stopcock. And that's why I'm rapidly opening and closing the stopcock. Now we're ready to titrate. And using a funnel, I fill the burette with sodium hydroxide.
Is this a step that some kids don't do carefully and they overfill it?
They overfill it. That's happens every semester, or the stopcock is not put on properly, and it falls out, and the whole lab bench is flooded with.
So you're literally dropping the base.
Yeah, dropping the base. Boop, boop. All right, so our titrant is ready to go.
Now, do you need to fill that right to the line?
You can fill it to the line as long as you are taking readings at eye level and reading to the bottom of the meniscus. Once again.
So you don't need to fill it to the top because you're starting from wherever you measure.
That's right. And typically the initial reading for trial 1, the first try that you do this for, becomes the final reading for the second trial until you have to refill the burette. So whenever you place a liquid into a tube, it forms a curved surface called the meniscus. And we always read the meniscus at eye level to the bottom of the curved surface, to the bottom of the meniscus.
To avoid parallax.
To avoid parallax here, that is right. And a pro tip is to use this meniscus
Oh, that's a
finder.
fancy thing.
It's a card with a black line at the bottom. A burette is set up to measure volume of titrant delivered. So the zero's at the top, not at the bottom. So it's a 50 milliliter burette, 0 milliliters at the very top, 50 milliliters at the bottom. Burette can be read to 2 decimal places.
So we are estimating.
We are estimating that second decimal place, a significant figure. 1.25 milliliters.
And that is our start.
Base reaction, we're going to use phenolphthalein as our acid-base indicator.
What happens if we forget to put this in, Zdog?
We don't put the indicator in, we're not going to get a color change and be able to note our endpoint to the reaction.
So you have kids that use an entire burette of chemical waiting for the endpoint. And then they're like, when does it end? And I go over there and talk to them. And I put 1 drop of indicator in and it turns so pink my eyes bleed.
Back to our pipetting skills. Avengers!
This is the greatest crossover of all time, kids. It's all of the solution chem coming together.
All of the solution chemistry lab skills, and in addition, all of our problem solving and calculation skills of solution chem and stoichiometry. All set for our first trial. Notice on the lab bench I have a white sheet of paper to serve as a background to better identify our indicator endpoint.
Because without that, you would see kind of blue, really.
We are mixing the solution, swirling by hand. Sometimes in our lab we'll use a magnetic stir. Those are always a big hit.
Now you have kind of an idea where this is going to end.
That's right, and often in our first trial, we want to get that rough idea as to where the endpoint to the reaction is, and we'll sometimes overshoot that endpoint.
No.
Our goal is to get a light pink color here at endpoint.
Oh, I missed it. Okay, whoops. Sorry, guys. The magic happened when I was zoomed in on the wrong thing. All right, that's a nice endpoint.
Give me a close-up of this end.
Yeah, that's what
It's a little bit too far.
I'd say it's a little on the pink side, yeah. So Zdog's going to take the reading, and then he's going to put that on the table, and when we subtract that, that gives us how much we've used, which is pretty handy.
All right, that's 14.10 milliliters.
Holy cow, okay. Now, you guys are going to do the math. So you're following along. These values you have to put into the worksheet that you're going to get, okay? So we're going to blast through this and give you a few more so we can move on to you guys can move on to the calculations. Boom, tag out. So Zdog did a great job. We got, I don't know, 13-ish milliliters used. Oh, that's spoiler alert. You guys got to figure that out. So we have to do multiple trials to make sure we have a nice average. So we need to try and get multiple volumes of sodium hydroxide that's the same before we decide to shut her down. When we do this in regular chem, we are constricted by time. Those of you in IB and wanting to continue in IB, how close do each trials have to be, Zdog, if you're going to continue next level?
Between
0.1 or 0.2?
plus or minus 0.1 milliliters.
Yes, you have to be pretty accurate. We're a little more lenient with the 20s. I think sometimes we're just happy we get through the lab in time. Okay, so here we go, round 2. This is going to be fast forward, and I'll show you guys a new technique, okay? If you want to do a half drop, what you can do is touch the side, and sometimes the drop will make it all the way down, and you might have to give it a little squirt of water there to get her all the way down, but this one made it actually, so I don't need to do that, and give it a little swirl, and we can see it's very faintly pink. Would you say to stop there, Zdog, or go a little more?
I think you nailed it.
Yeah, that's
Mr.
a nice,
Zed.
that's a nice, very faintly pink. Okay. So our reading is using this handy dandy thing here.
Meniscus finder.
Yeah, okay, so I got, each of these gradation lines is 1 milliliter, right?
1.1.
0.1, I mean, yeah. 27.21. So our initial is 14.0. Okay, we didn't show you, but we did some subsequent titrations. We did 4, and we actually ran out of sodium hydroxide, so we had to refill the sodium hydroxide to do it because it only holds 50. So this is another lab skill that I've seen some students forget about, is they use so much of the sodium hydroxide, they get so down low that they do another trial and they don't have enough to use, and they go below the last gradation lines where there's no measurement. So if you use into this danger zone here, you have no idea how much volume you used. So if you get close and you're like, oh, we're using about 13 each time, and if you're at 40, last time I checked, 40 plus 13 is a little more than 50. Be on the safe side and refill the burette. And remember, you don't have to get it all the way up to the top. I filled it to 1.32. Like, you just get close and you start again because you subtract and you get it. So you guys will have to subtract the values, find the 3 best ones, and average those for the math to find the concentration of sodium hydroxide, because you will need that for the second step of this, which is the vinegar titration. And Zdog's gonna tag in here and explain the setup start for that. It's kind of the same thing, but it's cool because now that we know this, we can find another.
Okay, so we're back here with part 2. Your goal is to test the manufacturer's claim. Co-op Gold Vinegar states on the label that the amount concentration or percent concentration is 5%. In chemistry, that would translate to 0.83 moles per liter. So titration is an analytical chemistry skill that can be used for testing consumer product claims like this. So we're off to part 2. We're titrating vinegar with 10 milliliters of a specific amount concentration of sodium hydroxide, which you need to calculate from part 1 of the video. Here is part of the balanced equation. Acetic acid is the active ingredient in vinegar. It's going to be reacted, titrated with sodium hydroxide in an acid-base neutralization, a double replacement reaction producing 2 products. Can you predict what products will be formed there? Once again, our titrant in the burette is sodium hydroxide. Mr. Zed has loaded the burette. It's all ready to go. Our sample or analyte is the vinegar, and remember that's acetic acid. Once again, we use phenolphthalein as our acid-base indicator for the neutralization. Adding 2 to 3 drops of indicator.
Why does it turn pink though? Like, I explained this in the video you guys would have watched on Friday, but.
Well, remember, phenolphthalein has a color change between a pH of 8.2 to 10.0. So as we're adding base to the acid, the pH is rising as the reaction is completed.
The first hint of the color change, the reaction is completed. There's no more acid to basically buffer the base.
Now this vinegar has been diluted 5 times, so we have 1/5 the original stock concentration.
You'll see that in the step on the worksheet we're going to make. The last step is to times your final calculation by 5.
And that way, by diluting it by a factor of 5, it takes less time and less costly sodium hydroxide titrant to reach our endpoint. So I've pipetted 10 milliliters in, and we're going to go through our first trial here on camera.
All right, I forget where this one stops. Do you remember, Zdog? I guess we're going to find out together.
We're going to find
I
out.
knew the other one
together.
was around where it stopped before.
Kind of right in that 13 milliliter
Yeah,
range.
I was going to say like 11.
11, okay.
We'll see. Oh, that looks like we're getting close there already.
Getting down to 8. So when you get closer to the required volume, you slow the titration down to about 1 to 2 drops per second.
No, I'm wrong. It's more than 11.
Well, you're not.
No?
You're still in the ballpark.
Oh, we're still there? Okay. You'll see it. I call it a color flash. What do you call it when it starts to make a little tiny quick pink?
Yeah, I like that. Color flash. Just
Yeah.
initial stages of that endpoint.
You can see it on camera right now. It's really subtle, but every drop in there is giving Zdog like a little pink. Oh! She's done.
Patience, dog.
There we go. Got her. Okay.
And I'm getting 14.85 milliliters.
Zdog is right. That'll be around 13 when you do the maths. Good. Okay, so we did subsequent titrations. You can see all our data's there. All of the colors at the endpoints were light pink all the way across. So the first one was light pink. All of the other endpoints were light pink. You still need to subtract these and see if they're all good data. Throw out bad titrations. Remember, we talked about that. Bad titrations you don't use in your math. So as a recap, you'll see in the assignment there's a series of steps to go through and a recap to this. The first step is you're going to have to solve the moles per liter of the sodium hydroxide. Okay, that's your first step. Solve the moles per liter of the sodium hydroxide. Then you're going to use the moles per liter of the sodium hydroxide to solve the moles per liter of the vinegar. If you do not do this step, you cannot do this step. So that's why this is a linked or chained question. The last thing you're going to do is times this by 5, and you're going to compare this to 0.83 moles per liter. And we'll see how close we are to what the manufacturer says. Though I don't know what we should do if they're wrong. Like, are we going to sue Gold Brand, Costco, Co-op, Vinegar Company? I don't know.
Letter writing campaign, social media campaign.
Can you imagine?
We got options.
Hey guys, we found out you weren't 0.83 moles per liter. They'd be like, send us some free donuts or something. Go away, nerds. Anyways, you can see though that this would be way more serious if you're the one selling vats and vats and vats of this and it's off, or something crazy expensive like the stuff in medicine. You don't want to be off at this stage. Okay, that's our show. Time to do the math, guys.